All right, so let's get started, ladies and gentlemen. We got two kinds of problems to work on today. It's a lot more cross multiplying, but you got to put your brain around how to set it up. That's where the pieces, that's where the question marks come from. All right, so let me get a ruler. I think I'm going to need that, but we'll see. Okay. First things first. Okay. Everyone got a ruler? Everyone ready to go? Okay. All right, so the problems that we're going to be working on today, or the first of two kinds of problems we're going to be working on today, all have the same kind of weird shape. They've got three parallel lines like this. Okay. And they're going to give you some of these lengths here off on the sides. I'm going to tell you that this is 6 and this is x. And I'm going to tell you that this is 10 and that this is 4. All right. Now, what's cool about these problems is that sometimes they're pretty straightforward in how to set them up. And in fact, the whole idea here is that the 10 and the x are related to one another, and the 4 and the 6 are related to one another. Okay, that's the idea, is that this length and this length kind of go together. So what we can do is we can just go ahead and set up a proportion right away. The 4 and the 6 are related, just like the 10 and the x are related. And now it's just a matter of cross multiplying. All right. So setting up these problems kind of comes down to connecting parts on either side. So like the 4 and the 6 are related to one another, and the 10 and the x are related to one another. And so that's how you can decide how to set up the problem. Okay, the pieces that go together. So has anybody solved this one yet? I've set up the proportion for you. Nice. Okay. Okay, so we're going to cross multiply. 4 times x is 6 times 10. So 4x equals 60. And now we divide by 4. And x is 15. Okay. Let's try a slightly different one. Okay. Okay, so do we see, how these pieces would connect to make your proportions? Because that's really the big key here. Okay. Now the next one you're going to have to do a little thinking about before you can put it together. All right. So I'm going to tell you that this, from there to there, is 9. And this piece is 6. And then this is 5. And this is X. All right. So going back to what we talked about in the last problem, I'm hoping that everybody sees that the X and the 6 are going to be connected, right? They're going to be proportional to each other. But the 5, we don't have right away what its part is. But can anybody tell me how big this green length that I just drew is?
3.
Yeah, it is. And we know that because if this whole thing is 9 and I don't want the 6 part of it, if I take 6 away from 9, I'm left with 3. So this one required you to do a little bit of thinking in advance before you just start dropping stuff into proportions. All right. So now we know the 5 and the 3 are related. And the X and the 6. Okay, good. So we cross multiply. 3 times X and 5 times 6 is 30. And now we divide by 3. And so X is 10. Okay. So what this problem, I like this problem because it made you do a little bit of thinking before you got started. But here's what I want to do. I want to show you another way to, I mean, not another way, but a way to solve these problems by figuring out parts, okay? So don't copy this down, just watch me, all right? I'm just going to redo this problem. And since you've already copied it down, you don't need to follow and do this one again. You just have to look at me and see how I'm doing it a little different this time. All right, so I'm just going to remake the problem. Like I said, we already know the answer is 10, but that's a 9, that's a 6, that's an X, that's a 5, right? Yeah, okay. Okay, so here's the thing. And we're going to see other problems down the road where this is the way to go. Okay, this is the way to solve it. So I think we all see that the X and the 6 are related. We already figured that part out. Now, the 9, it's the whole length, right? And so the 9 would be related to this whole length. Okay, because remember, it's all about matching parts up. And so the 9 talks about the whole length. Well, this is the whole length. And since it's made of a 5 and an x, it's 5 plus x. Now, you might be saying, hey, Rongo, I don't need to be doing all of that. Well, in other problems, which we'll see in a minute, you might. So let me show you how that it still comes up with the same answer. So the x and the 6 definitely go together. And the 5 plus x and the 9 go together. And now when we cross multiply, got to distribute. And I want all my x's in one place. Subtracting and dividing. X is 10 again. So it still works. And the trick that I was trying to show you was that the 5 goes to this space, which we already a few minutes ago figured out was 3. 5 goes to 3, x goes to 6, 5 plus x goes to 9. Pieces match up, and that's how you make your proportions. So this next example that we're going to do, you need this kind of thinking. All right. Which one? This one. Okay. All right. So the way you look at these problems is you, just like with the triangle problems, who matches with who? Okay. So can anybody tell me something that matches up as a pair?
$35 and $20.
Yeah. The 35 and the 20 are one of your pairs that you're going to be making. Now, that's great. Okay, but I got to get the X in this game too, because remember, that's the job. So, get another color here. Kind of burning through my markers. All right. So now we got to figure out what to match the X up to. And the X is talking about the whole thing. So I need to match it up with the whole thing. How big is that one?
32.
Right, because it's 20 and 12 put together, which makes 32. And you see, now I've got things to match up with things. And now you can set up your proportion. So let's do 20 over 35, because we knew that that was a pair, and 32 over x, because we know that's a pair. That's a 3. Doesn't quite look like a 3, but it's a 3.
I have a question. So if you were working from bottom to top, could you do 35 over 20 and x over 32?
Yeah, you could. It would be exactly the same as, I mean, think about it. If I drew the picture this way, right?
Oh,
That
yeah.
would, it would do, you would do the same thing, right? So yeah, it would still work.
Okay.
Good question. Anybody else come up with an answer? It's okay if you get big numbers. You're going to wind up, you know, you got big numbers in the problem, so you're going to get big numbers in your answer. Okay, so let's cross multiply. 20 times x is 20x, and 35 times 32 is 1,120. And now divide both sides by 20. X is 56. And you know, it's always good to kind of like look at your answer and say, does that kind of make sense? Well, we know it's got to be bigger than 35, right? Because we've got this here. And so, yeah, I mean, it looks like it's a pretty good size number, you know? Cool. All right. Let's do another. This time I'm going to kind of leave my hands off of it. You guys can kind of figure out what to do. Okay. Okay. I'm going to tell you that this is 8 and that is 4. This is x. And this whole thing is 15. So this one I'm going to let you go on your own. Okay. So I think, and I'm hoping that we all see that the X and the 8 go together. Okay. Now we need another pair. And we can do the 15, the whole thing. And that whole length would be 8 and 4, so 12. Okay. So we've got two sets of pairs. We've got, let's do 15 over 12 is X over 8. Now when we cross multiply, 12x equals 8 times 15. 8 times 15 is 120. And now we divide by 12, and x is 10. Okay. How are we feeling about all this, ladies and gentlemen? Doing okay? Okay. Anybody out there drowning? Okay. Hope not. A lot of quiet people today. I'll be honest with you, ladies and gentlemen, it doesn't get too hard after that. Those are the hard ones. Unless I threw in some algebra, which is, you're like, no, Ronco, there's no need for algebra. Some would argue against you on that. When was the last time I went to the supermarket and had to use algebra? It's a good question. You probably never will. However, you do go to the grocery store and try to figure out how to save some money. You want to try this one on your own, or you want to go when you want me to show you? That's great. I had one person say show us and one person say on her own. Okay, that's cool. If you're on your own, just turn your speakers off for a minute. And okay, let's do it. So the 6 and the x plus 2 are definitely a pair. And the 15 has to match up because 15 is the whole thing. So we need to find out what that whole length is over here. We need to find out what he is. And to go from there to there, you're going 4 and 6. So that's 10. And now we've got our two pairs, the 6 and the x plus 2, and the 10 and the 15. So 10 and the 15 are one pair. 6 and the x plus 2 are the other. Okay. Cross multiplying. And I'm going to tell you guys, if you reduce your fractions, this is even easier. I'll show you what I mean in a minute. Now, for those of you who don't like all this algebra, let me show you. You could have done it with no algebra. And you're like, well, Ronco, please show us. Watch. I'm going to reduce my fractions. These are both divisible by 5. And when I divide them both by 5, I get 2 over 3. Now, here's a trick that they never teach you in algebra, but you can reduce sideways. The 2 and the 6 are both even. And now when I cross multiply, I don't even have any distributions left. And you're done. Reduce your fractions. Saves you a lot of problems. So, just in case you wanted to see that again, you try this and try it by reducing your fractions. Try solving that just by reducing your fractions. So 21 and 12 are both divisible by 3. And so 21 over 12, when I reduce that fraction, what does it turn into?
Seven over 4.
Yep. And now if you look across, you'll see that these are both divisible by 7. And now when you cross multiply, you're done. So I'm telling you, if you just know your multiplication tables, if you look at numbers and you say, oh, that's on my multiplication tables, and reduce your fractions, life becomes so much easier. And you're like, oh, well, you know, hey, Ronco, life's easy with a calculator. I don't really even need to do anything. I just push the buttons. Well, you know what? Pushing buttons on a calculator doesn't make you better at math. doing math makes you better at math. Okay. So let's do some more. Ooh, that'll be fun. When a math teacher says, ooh, that'll be fun, you probably are saying to yourself, no, no, it won't. Remember, math teachers have problems. Okay. That's 4. That's 5. That's 10. And the whole thing is 5x plus 3. All right. So let's start putting it together. We got a 5 and a 10. So I'm just going to go ahead and put that down. I know I'm going to need it. And this guy is the whole length, so I need the whole length. And 5 plus 4 is 9. So 5 over 10. I went top over bottom, so I'm going to go 9 over 5x plus 3. Now I'm going to reduce this fraction. So that this way I don't even have to do a distribution. And now subtracting 3. And now dividing by 5. You see, just by reducing one fraction, I mean, 5 over 10, you know, that's not bad. By doing that one step, it saved me the trouble of doing big multiplications and other steps and blah, blah, blah. Saved me a little bit. Saved me a little bit of work, saved me a lot of work later. Okay. How are we feeling about all this, ladies and gentlemen? Scale of 1 to 5, how are we feeling about all this? Okay, then. All right. So let's talk about the other kind of problem that I want to show you today. Okay. This is no, I want to see this. Okay. Let me show you how they look. They look, okay, start with a triangle. And from one of the corners, split the angle in half. Okay, so here's this angle bisector. Now, I'll set up a problem and show you how it works. Okay. So we've got in this problem, okay, so this is a new kind of problem, all right, and it starts off with a triangle and an angle bisector. I know it's an angle bisector because of the tick marks, okay? Now, what's kind of nice about these problems is that you're kind of already looking at the proportion. You see how the pairs are already kind of like right in front of you? And now you just cross multiply. It's really not that bad, but we're going to see how the you know, some information is going to maybe make us think a little bit. It's not going to be too bad. Yeah, it's really not bad, right? Okay, good. Cross multiplying, you get 4x and 24. Dividing by 4, x is 6. Okay. So before we go any further, let me ask you a couple of questions. Got to make you think about how these next parts work. Okay. So just some old school, like adding and subtracting segments and stuff. If I tell you that the whole thing is 10 and this is 4, what's that part?
6.
Yeah, you just subtracted it, right? You said 10 minus 4, and that gave you 6, right? Okay. I want you to keep that idea in your head. Okay. So if the whole thing is 20 and this part is x, what's that? I threw in a variable and everybody panics. Well, up here, what did you do? You said the whole thing minus the 4. Well, here we are, the whole thing minus the x. So what about this one? If the whole thing is x and this is 3, what's that part? Follow the same pattern you did before. So I did 10, took away the 4, gave me my 6. 20, took away an x, gave me 20 minus x. X, take away a 3, gives me x minus 3. Okay? How do we feel about that? Scale of 1 to 5, how are we feeling, ladies and gentlemen? I believe all of you. I don't even think people are answering the question. If the whole thing is a farm and I take away a cow, I have a farm minus a cow. That's the idea. Doesn't matter what's in these places, whether they're x's or numbers or what. It doesn't matter. Okay. All right. So let's do this one. So definitely the 12 and the x go together. But I need the part that goes right there to go with the 16. So like we were talking about before, if that's X and I don't want it, I take it away. Now you can set it up. Okay, so try this one. This one's not so bad. The X and the 12 are going to go together. And the 28 and something over here is going to go in. How we doing, ladies and gentlemen? How big is this? Somebody unmute and tell me how big that is. Somebody who doesn't have their mouth full. Please don't choke. Right, Blake, it's 21. Very good. Okay. Thank you for saying. All right. Now we can set up our proportions. Let's do x over 12 is 28 over 21. Right. That's right, Liliana. We can reduce that fraction. And they're both divisible by 7. So that's 4 over 3. Very nice. Thank you, Vanessa. We can reduce the sideways as well. So this is 4 over and 4 over 1. And now when we cross multiply, x is 16. There we go. Very well done. Okay. Okay, Alexa, we can do another one. That's cool. Okay. Now, I bet that if you look carefully, you could solve this problem without even putting pencil to paper. But you're always welcome to solve it with pencil and paper. Right, Jalen? That's good. Good catch, Shemaine. That's right. 8 and 4. Well, you're just dividing by 2, right? So if you divided by 2, that would be 7. And so x is 11. Nice catch. Looking for scale factors. Very nice, Shemaine. Okay. Now, let's say you didn't do that. You would have come up with this instead. This is 14 all over x minus 4 is equal to 8 over 4. And now when we reduce that fraction, and reduce it sideways, and now when you cross multiply and add on to the other side, you get the same thing. Good question, Deborah. Yes, it's always like that. But sometimes it's hard to see. Sometimes, you know, that scale factor from there to there isn't a nice, happy whole number. All right. Great. Let's do a nice, easy one. Anybody else? Okay. All right. That's excellent. Everybody's answered this problem. Fantastic. 10 over 6 is x over 9. Yup, we can reduce a fraction again. That's really good, Fernanda. 5 over 3, x over 9. Angelina, you're right. You can reduce sideways. Let's see, and now when you cross multiply, life is really simple. There we go. Okay, so how do we feel about all of this? Everybody, scale of 1 to 5. Okay. Well, how about this? We've got about 25 or 23 minutes. Why don't you guys hop on over to IXL? So Canvas, IXL, and then do, Canvas, then to Clever, right? And then to IXL, and then go to P10. That's that's all the stuff that we worked on today. Okay, and then you can just get done with your homework and you'll be all caught up and everyone will be finished. All right, head on over there and I will see you over there in a minute.